Hello students, welcome to chapter 14 mathematical reasoning. It means students it is a logic. Yes, mathematical logical reasoning. This chapter is very easy and very simple. First of all, going ahead in the first topic, it is a statement. Yes, it's topic wise I explain in the chapter. Statement means students a sentence have true either false. Yes, true either false. Any one meaning are possible in that statement called that, and in a sentence that. So in a statement have just like a one of the P. There are two chances, true either false. That the two chance for true and false. But if you not given chances for true or false, just like a exclamatory mark, order, request, question mark, that not a statement. Yes, so in the exercise 14.1, just describe given line are statement or not. So I just one by one explaining very clearly. First, there are 35 days in a month. Students, in a month have 35 days not possible. It is a wrong statement, but it is sure statement. You can write down yes, it is statement. It is a false statement, but it is a statement. Second, yes, mathematical. Yes, mathematics is difficult. So students, some students have a difficult, either some students are easy, so they're not sure it is a true or false. That's why it is not a statement. Yes, it is not a statement. Third, very easy, the sum of 5 and 7 is greater than 10. You know that 5 plus 7 is obviously greater than 10. It is a true statement. I will write down yes, it is true statement. False if you given, then also statement. Yes. Fourth one, the square of a number is an even number. So sometimes the sum number is even, sometimes odd. Yes, sum of the square, just like a 1 square is 1, but 2 square is 4. It is odd. Here even. Confirm the not sure. Therefore, not a statement. Yes. Continue. I going ahead. Question number 5. In the fifth, very easy. The sides of a quadrilateral. Sides of a quadrilateral have equal length? No, sometimes equal if a rhombus given and square given, but sometimes not equal. It is not sure. So here not statement. Next, sixth one. In the sixth, answer this question. Answer this question, but which question? They're not sure. So this is also not a statement. Yes, not a statement. It means if you clearly about that true either false, that's your statement. Next, seventh one, the product of -1 and 8 is 8. Definitely -1 and 8 product is -8, but here 8 written, but it's false, conformly false. So it is a false statement. Yes, it is false statement. That's why I will call it is a statement. Now 8, the sum of all interior angles of a triangle is 180. Sum of the interior angles of a triangle 180. It is a true statement. Yes, it is true statement. Indirectly it is a statement. Ninth, today is a windy day. It is not sure. Today is a windy day. Some persons have windy day but some not, so it is not a statement. And last, 10th one, all real numbers are complex number. Yes, all real number are complex number. So does all real number complex? It is always true. Yes, so it is a statement. Yes, it is a statement. So here basic introductions to into mathematical reasoning. Our statement is done. They have two chances, either true, either false. But if you sometime given question mark, exclamatory, order, either that they request that not a statement, otherwise true and false types the statement. Now I going to second topics. It is called negation of a statement. Yes, second meanings, very easy and simple exercise. The topic second, negation of a statement. Means you know that a statement have two cases, either true, either false. Here I write down negation, just like this symbol. This opposite S is the negations. True then false, but false then true. Just like I called here, Gandhinagar is a capital of Gujarat. Negation, Gandhinagar is not a capital of Gujarat. Similarly, Delhi is a capital of India. So negation, Delhi is not a capital of India. Yes, that types we going ahead. Our exercise 14.2. Convert the given statement into the negation statement. Yes, very easy and simple way going ahead. Write the negations. First, Chennai is the capital of. Yes, Chennai is the capital of Tamil Nadu. So I just only change this statement is not negation. Chennai is not, this only change, the capital of Tamil Nadu. Second, very easily students, you describe your negation parts only to change in true to false and false to true. Root 2 is not a complex number. So I will write down negation P. Root 2 is this not a remove. Root 2 is a complex number. Third, all triangles. Yes, all triangles are not equilateral. Equilateral, yes, triangles. So I only change the negation. All triangles are not removed. Negation P. All triangles are, these are removed, for the negations are equilateral triangles. Next, continue moving in the fourth one, and fourth one also students are similarly going. The number 2 P statement Yes, the number 2 is greater than 7. Number 2 is greater than 7. Only here I write down. Number 2 is not. So negation P, the number 2 is not greater than 7. Now fifth one, also same running. In the fifth, every natural number is an integer. So only this a change. Is not an integer. Negation P, every natural number is not an integer. And that's why students, I just cover my answers to simple way. Now question first over. Second, are the following pairs a statement or not? I only just reading and verbally I explain. Students, the first one given, the number is not an irrational number. Second, the given its negation, the number x is not an irrational. Yes, it is a negation of the first. And second one, the number x is a rational number. And second, the number x is an irrational number. Here also true, because first number the negation are second given, the number x is an irrational number. Now I going to next topic, and the topic number second, it is a composite statement. I mean compound statement. Compound statement. And after that I will start my question number third. In the compound there are two ways. Either and, either or. Two way I connected my two statements. So P, Q. Here write down P and Q, just like P conjunction Q. And third, P or Q, just like P conjunction Q. These are the explanations by the compound statement. Students, you know that a P have true false. Another statement also true false. So I have here that two chances, true true, true false. That's why I write down true true, true false. And second, false true, false false. Only 4 chances are available in this criteria for connection by and or. Now if you end connection, whenever you end, false or answer is false, both true then true. Any one false, you can show them all are false. If you true, then you can become students here true. Now in the these conjunctions are true, 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 both false, then answer is false. In any how the false, both false. And here only true if the both data is true. So now students, after that we going ahead and an or related compound statement, our question number 3, and decided that your true false statements and 2 compounded with the and or. So find the compound statement, following compound statement, and check their true or false types. Question number first, third one. Number 3 is primes, I mean prime, or it is odd. So this or is indicate that one. So disjunctions, that is your P, that is your Q. So we will write down here P, number 3 is prime, definitely it is true. And Q, number 3 is odd, it is odd, confirm that true. So my component over or this over, now next truth value, P disjunction Q, true disjunction true, my answer is only and only true. Now second, yes, all integers are positive or negative. These or are the our find out the component statement with this P and that the Q. Yes, so I will write down P and Q. All integers are positive. And all integers all are positive? No, they not always are true. Second, all, sometimes the negative also possible. Integers are negative, and that is also false because sometimes the positive. So P or Q, false or false, it means that my answer is only and only false. And the third one, my third statement, 100 is divisible by 3, 11 and 5. So students, it is a divisible and connection given. This is the end. It means this one. It is a two statement by explaining you, but now I go and hit 3. So my statement is a P Q R. 100 is divisible by 3. 100 is divisible by 11. And 100 is divisible by 5. This is a not divisible, false, but that is true. But I want to P conjunction Q conjunction R. So false conjunction true. Overall my answer is false because no chance to applying in false into false. My answer is false. Here students, this is over for this exercise. Now moving ahead. Slowly, next topic. And next topic is that special word phrases. We are going in the parts of same running exercise 14.3. Yes, similarly explaining compound statement break into each following compound statement. First identify the connected word, means connect by and or, and break into component statement. Exercise 14.3. First one, all rational number are real and all real numbers are not complex. Students, the conjunction is that and my target asking each of the following compound statement. First identify their connecting word. So here we write down connecting word. It is a and two parts P and Q. Simplified it. First, all rational numbers are real, and second, all real numbers are not complex. Only asking that, are not asking here true and false. Here true false asking, that's why I explaining that. Now second one, square of an integer is positive or negative. Students, here also just you identify your connecting word by or, only and or. So my answer is a connecting word is a or. And in the answer parts P Q, here write down square of an integer is positive, and second, square of an integer is negative. Only two statements, write down P and Q. Now similarly students, I will explain to third one. This side write down. Third also same as much as that third. The sand heat up quickly in the sun and does not cool down fast at night. So and you take highlight and P and Q statement calculate. Yes students, here only I just verbally explain. Now fourth, x is equal to 2 and x is equal to 3 is the root of the equation 3x square minus x minus 10 equal to 0. So and here connecting word, and x is equal to 3 is a statement for the equations 3x square minus x minus 10, and second q, x is equal to 2 is also equation 3x square minus x minus 10. That's the easily done. Now question 2, identify the quantifier. It is a new topic. So students, here heading for, there are two quantifier, two types of quantifier. One of the universal quantifier and secondly exponential quantifier. Yes, universal quantifier. Yes. So first type is a universal quantifier. Just like a for all, either you can say these types of equations. This is a symbol for every member in a set. I can select that, call it is a universal quantifier. And second type, yes, exponential quantifier. Exponential quantifier means for particular only one, I mean there exists either this symbol, there exists me students only particular one, either two, sometime rarely case two, but only first one time two elements are if you selected, that is called your exponential quantifier. So in the two-way exponential and the universal that given that types questions. Now these are negation to universal to exponential negations and negations to universal exponential negations. So my question start now. 2 is this way. Identify quantifier in the following statement. Write its negation also. There exists a number which is equal to its square. Students, here this underline first of all, there exists means exponential quantifier. First I write down there exists, indicate exponential quantifier, and my negation is only this I change, there exists converting into for all. So for all number, either write down for every number which is equal to its square, but I write down which is not equal to its square. That's my answers. Now second, similarly second going for every real number x is less than x plus 1. So it is here also I can make first underline for every. It means that one our universal quantifier, I just converting exponential quantifier means there exists. So here write down first of all for every, indicate what? Yes, for every indicate your universal quantifier. And my negation is same. I going to negations. For every I remove and write down that there exists there exists a number, either a real number x, x is less than x plus 1. I write down x is not less than x plus 1. Now continue, third one. Similarly moving, same as that calculations. Question number 3. In the third way, there exists, question is very easy, there exists a capital for every state in India. The given that, so here there exists, first I make underline, it means your extensional quantifier. Yes, here there exists, indicate, yes, that one, extensional quantifier. So there's only two types of quantifier there, universal and extensional. And negation, very easy, I convert in negation. There exists change for every state of India have not a capital. There exists a capital for every state of India. I just converted, for every state of India have not a capital. And that's the students, your question number 2 done. Now third one, check whether the statement is a given for your negation or not. Very easy. First, x plus y is equal to y plus x is true for every real number x and y. And second answer given, there exists a real number x plus y is not, is equal to y plus x. Indirectly it is wrong given, it is not our negations. You can write down x plus y is not equal to y plus x. Then they become the true. Indirectly your answer is written the false. And fourth one is a now new topic, or meaning is a new topic, or are using to inclusive sense or exclusive sense, or using in inclusive sense or exclusive sense. So does inclusive or exclusive sense, before I explaining to textbook numerical, I will go to one example for you. Consider in a same plane, either two lines are parallel, L and M, either two lines are intersect each other, L and M. So here L parallel M, either here L intersection M at a point P. So students, you decided in a same plane, this possible if you, then that not possible. Either in a same plane, intersection possible, then parallel not possible. So anyone is true, then you can apply exclusive sense. Here using or is exclusive sense. Yes, if you both true, then you can apply to inclusive sense. Now I go to verbally in the question 4. Sun rises or moon sets. Both are not possible. Not possible, both are not means it is the exclusive sense. Second, to apply for a driving license, you should have to ration card or a passport. So ration card and passport both are identity proof. ID proof. It means both are true, so it is a inclusive sense. And third, all integers are positive or negative. So does all integers, if a positive, they possible to negative? No, all are not positive. Sometimes all are negative. No, that also not possible. Sometimes positive and 0 also possible. Both at a time not true. That's why I write down it is a exclusive sense. So in your first answer exclusive, second inclusive, and third are our exclusive. Here students, this topic is done. Now I go to new topic, and one of the new is the biggest topic for implications. Yes, in implication wise. Now I explain. Here our half chapter is done, and other half chapter now starts in the simple way to implications. So new topic, implication. Implication means students statement P that imply Q. This is the correct meaning for implications. If P then Q, where P is one of the conditions, Q is also one of the conditions. Yes, P is a sufficient condition. But Q is always necessary condition. And in this way we can apply here also table to P, Q, and one of the way of P and Q. Similarly, here I go to P implication Q, and we will cover to by definition wise the whole values EFTT, FF, TF, TF. Whenever double false, you can write down true, and these answer exactly to Q. Means here T, false, and here T. Always, if you given these are wrong, correct written TT, double F then T, and this answer you can write down according to your last data P implication Q. If you written Q implied P, then also double F then T, and this answer to P cover. It means this one T, T, F. That's our meaning for a simple P. If P then Q. Second topic, you also connected the negation. Negation of P implication Q, and if you second one negation of Q implication P, that also students you by heart for MCQ. P and negation Q, here Q and negation P. This is are the two parts. Then after going to third topic, it is a contrapositive. Contrapositive, it is just like equivalent statement. P implication Q, you can cover the formula negation Q implied negation P, and last after that converse. Converse means P implication Q given. Sometimes you can write down converse Q implication P, and both P to Q and Q to P make it conversations. Here up to that your implications, and next topic is the last topic, that double implications. That is also I will show here double implications, because the all topics are combined in the one way. Yes, double implication means P in this way are both side given arrow, and the meaning is P if and only if Q, then you can cover this meaning to implications double, and here only if and then right, then a single implications, but that's the double. Here both P and Q are this one necessary and sufficient condition. Yes, sufficient and necessary condition. Yes, students, both are sufficient and necessary conditions. For both way, if you double implication given, and at last I draw the table, and this table is a P with the Q, systematically P implication Q, Q implication P, and that last P double implication Q. It means P implied Q, and yes, Q implied P, and means students conjunction. This conjunction already I explained in the last part. So here are T, T, F, F, TF, TF, and here I can show the answer. This again same write down. Yes, double F then T, T F T. Here double F then T, P related, T T F, and both conjunction. It means students these are. I will show to in conjunction part. Double T then T, F F, and here T. These topics are related. And last part, negation of double implications. Double implication meaning means P implied Q and Q implied P. And means negation, students. You can show the or, means negation of P implied Q or negation of Q implied P. And that's answer. These are already written here. And answer show up that negation of P implied Q is converting into P and negation Q. Otherwise, Q and negation P. These answers are the negation of double implications. These are single implications. That meaning necessary, sufficient, and there is a true false values are that negations. After that, contrapositive means equivalent statements. Converse, double implications, the meaning, definitions, and this table, and that's our students negations. Now I will start my exercise. Legal exercise, very easy sums, and slowly I will going ahead in the way of one by one. So in exercise 14 point, now 4. In the implications wise, rewrite the following statement with if and then 5 different ways converting in the same meaning. Yes, exercise 14.4. First one, if a natural number is odd, then its square is also odd. Students, here I just write down 5 different, but here if to then given, so that's your P, and here our Q. So first I write down contrapositive. Yes, contrapositive wise, P implication Q is a negation Q, implied negation P. So write down same. If here Q negation means that negations a number square is also odd, so is not odd, then P negation. Now this one, its number is not odd. That is the first line. Second, for every natural number is odd, then its square is also odd. There exists third one. There exists a natural number is odd, then its square is odd. Fourth write down are necessary and sufficient related. If a sufficient for a natural number is odd, then a square is odd. And last, if a sufficient for a square is odd, then a necessary that a natural number is an odd. To different way, 5 ways we can write down. Now I go to question number 2. That's all I will read here. Write down the contrapositive and converse. Find contrapositive and converse. Very easy. If x is a prime number, then x is odd. So we going ahead, students, method wise I will slowly explain about that. This is your P, then after that is your Q. So P, that's the P, That's the Q. And I will explain first contra positive. So contrapositive is formula P implication Q is a negation Q implication negation P. So we start if this is a negation, X is not odd, then negation P, students, X is not a prime numbers. And now second, I just asking that a converse P implied Q, which is Q implied P. I will write down if this only Q, X is odd, then X is a prime number. That's the answers. Now secondly, question second, also same running. If the two lines are parallel, then they do not intersect in the same plane. Students, here also I just two partitions. If the two lines are parallel up to P and another after that Q. So first contrapositive means a negations that P implication Q is equivalent. Negation Q equivalent negation P. So here I write down if these negations, if they do not intersect in same line. So if two lines are intersect, do not I remove that intersect in the same plane, then now these are, it's parallel, no it's not parallel, then it's not parallel. And converse P implied Q, that is Q implied P. So here write down if, simple way to statement, and then after students we can write to first of all Q, after that P. So in the converse students, if a Q, then I taking they do not intersect the same plane, only direct write down, they means two lines are not intersect in same plane, then now P is that it are parallel. Students, it is a parallel, and that's the simple way. Question second done. Third and fourth and fifth, students, you will write down as the same as. Now continue question number third. You will self calculate third, fourth and fifth similarly. Now question third have each of the following statements just converting into if and then. That also I just verbally explain. You can get a job implies that your credentials are good. So answer is, if your credentials are good, then you get a job. Second, the banana tree will bloom. It said that warm for a month. So you write down if it stay warm for a month, then the banana trees will bloom. Third, a quadrilateral is a parallelogram if it is diagonal bisect each other. So if the diagonals are bisect each other, then I write down then a quadrilateral is a parallelogram. And fourth, and get an A+1 grade, A star in a class is necessary that you will do all exercise of the book. So if you do all exercise of the book, then you will get A star. Yes. Now continue question number 4. 4 also I just verbally explain. Given statement A and B, identify that it is your converse or the contrapositive. First, if you live in Delhi, then you have winter clothes. So very easy. First given, they do not have a winter clothes, then you do not have live in Delhi. It is a contrapositive by this formula, P implication Q, negation Q, negation P. And second given converse. Converse is that if you have a winter clothes, then you live in Delhi. Second one. If a quadrilateral is a parallelogram, then the diagonals bisect each other. And here identify it is a contrapositive or converse. Answer is first. If the diagonals of a quadrilateral do not bisect each other, then the quadrilateral is not a parallelogram. That one also you have to contrapositive answers. And second, definitely converse. Converse given if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. And that statement you belonging to what? It is a converse. Here students, our exercise 14.4 done. After that 14.5 you not calculate. So I go to now our exercise 14. Yes, exercise 14 have all a mixing to all topics. Today I explaining that one by one. Exercise 14. In the first one, write the negation of the following. Find negation of the following. First one, P. For every positive real numbers, yes, real number x, the number x minus 1 is also positive. I just write down the negation, students. So these are changed for every. It is a converting universal to existential. So my negation P is there exists positive real number x. The number x minus 1 is not also positive. Yes, is not write down. And second, P statement. I mean Q given in your book. Book wise I mentioned all cats are scratch. So I written negation Q. All change there exist a cats have no scratch. Yes. Third, are the given third statement for every real number x, either x more than 1 or less than 1. Very easy. This for every, I first remove negation of r. For every, convert it into there exist. There exists a real number x, either x not more than 1, either you can write down greater than the opposites. This also true. Not less than or equal to, and here change x get less than to not greater than or equal to 1. Either you change in the way of another way. Continue fourth. S. My fourth S is given. There exists a number x such that 0 less than x less than 1. Students, here also there exists, I remove from that, and my negation S for every number x, this cancel. Yes, for every numbers, for there exists number such that 0 less than x less than 1, x have 0 not less than x not less than 1. That's my Easily question number 1 done. Now question number 2, students, contrapositive and converse. So you will try itself, and third also try to itself if P then Q related. So I will go to now question number 4. Yes, second and third you will try itself the statement. Now fourth is a IMP for exam. So question fourth one, second and third very easy, that's why I give you itself. Rewrite the following statement if P and only P then Q. So my write down P if and only, yes, I just read that again line, if P and P, if and only if Q, write down the statement. First, data is given P, if you watch televisions then your mind is free, and if your mind is free then you watch the television. So I write down here first statement, if and only if, yes, if and only if, here the Q, only anyone you can write down the statement. First statement I give you, you watch, yes, you watch television, if and only if, yes, your mind is free. That's the statement. Second one same as here, first if and only if the Q, and my data is for you to get an A grade, it is necessary and sufficient that you do all the homework regularly. So here you write down, you get an A grade if and only if you do all the homework regularly. And next, third one, same given, if and only if, I just given the statement, a quadrilateral is equilateral then it is rectangle, and if a quadrilateral is a rectangle then it is a equiangular. So write down a quadrilateral, yes, a quadrilateral is equiangular if and only if it is a rectangle, it is a rectangle. This indicates, students, double implication. If and only if indicate what? Double implications. Now question number 5, two statement given P and Q, connect with then and or and get the your true and false values. So in P given, Q given, 25 is a multiple of 5, and next 25 is a multiple of 8, and asking the compound statement connecting with and. So first I write down connecting with and. So very easy, P and Q, 25 is a multiple of 5 and 8. That's your students answer. But it is a true, but that is the false now. So my answer is P and Q, true conjunction false, whole data is false statement. That's your true and false type, your truth value. Second, asking connecting with the word or. So or wise I explain same, P or Q. P I have 25 is a multiple of 5, or 25 is a multiple of 8. So here also, students, you can disjunctions, P or Q, truth value, true, disjunctions false, false or true. but second is false. So my answer is to universally that true or false, it is a true. So therefore given statement is a true statement. Here students, your question number 5th also done. Now in the 6th, check the validity, you not apply that. And 7th, you can try itself. Write down the given statement in different 5 ways. Already I explained in the 14.4 first one. Yes, 14.4 first one related your 7 questions. And here students, our this mathematical reasoning chapter is easily and happily done. Okay students, bye bye.